A chest X-ray is the most frequently used medical imaging test worldwide. This is relatively a simple method to investigate health issues and pathology of the heart and chest, including infection, chest trauma, and malignancy, and is practiced around the world. However, diagnostics involving chest X-rays could have limited accuracy. Statistically, as per research records, due to erroneous interpretation of chest X-rays by radiologists and doctors alike, cancer diagnosis was missed in 90% of the cases. Even though chest X-rays are widely used in clinical practice, interpreting the images accurately is not achieved due to human errors or a lack of knowledge and experience of radiologists. A wrong or delayed diagnosis of such a key pathology creates type 1 error, resulting to the patient's exposure to future medical risks including cancer, pulmonary diseases, leading to complications and deaths. That leaves us with a very important life-saving question. Is there a way we can improve the interpretation from these medical imaging tests? This is a very frequently done test across the medical world, so it holds a special importance in this sector. Welcome to the case study in the application of computer vision and deep learning in the interpretation of chest X-ray images, which is carried out across a large breadth of clinical practice. In the medicine and healthcare sector, a huge amount of data gets generated by a distributed system of cameras and sensor machines. This vast amount of image data from medical devices and digital records can significantly increase the potential of computer vision and deep learning aided solutions in this space. Advances in computer vision along with deep learning techniques can make computers understand visual data. In this approach, the machine can be fed with raw data and it can develop its own representations needed for pattern recognition. As an example, a chest X-ray is presented to detect damage due to COVID-19 in lung tissues. With deep learning algorithms, very complex functions can be learned, which can lead to a high achievement of accuracy in image recognition tasks. So it begs us the question rather than the solution about how we can do it. By focusing on image and video understanding, computer vision will perform tasks such as object detection, image reclassification, and segmentation. And the application of deep learning will be able to achieve human-like performance in object classification work. This method, trained on a massive dataset, can be further fine-tuned on a sample related to the task of interest, such as the X-ray images. Experienced radiologists can annotate the images based on their understanding, which will serve as the training dataset for the deep learning models. Once the model is ready and implemented, this technique will assist clinicians in the interpretation of the frontal and lateral chest X-rays while covering a large extent of findings for clinical relevance. One such evidential study was carried out by a firm called Annalise.ai in the detection of pneumothorax and tension pneumothorax in chest. Another organization, an India-based high-tech startup called Cure.ai, has developed a product called QXR, which can detect multiple abnormal findings on the chest X-ray in less than 1 minute. The use of deep learning in chest X-ray analysis systems can automate lung segmentation and bone exclusion. It can aid in the detection of pneumonia, in the diagnosis of tuberculosis, COVID-19, pneumoconiosis, pneumothorax, and lung cancer. It can help in predicting temporal changes in image findings and in the diagnosis of many more such ailments. But at the very least, based on research evidence, it is found that coupling the use of deep learning models with radiologists will lead to a higher diagnostic accuracy and minimization of human-induced errors. The adoption and advancement of computer vision in healthcare can lead to the diagnosis of ailments with more accuracy. This will prove to be better than human experts to recognize patterns to identify diseases with minimal or no error. By scanning millions of medical images, these tools and technologies can aid medical professionals to be better able to identify, prevent, and treat several diseases. In conclusion, we can therefore say with a great deal of certainty that computer vision has already shown its capability and will only further grow in its potential for application in healthcare and medical imaging. It shows us the promise to improve patients' lives through accurate diagnosis and early warnings, and in the process eventually propels the healthcare sector further for the benefit of society and mankind. Hope you liked this video and thank you for watching. Don't forget to tune in to our other video case studies. Thank you for your completion. Stay informed with WITP's tailor-made online courses at igotkarmyogi.gov.in. Enroll to lead with knowledge, explore practical courses on emerging technologies. Deep dive into real-world applications through the WITP Digital Library and WITP YouTube channel. Your learning journey continues towards a tech-savvy, future-ready government service. Jai Hind.